science isn't just facts, it's stories. Nitrogen was the quiet roommate, stable, polite, mostly minding its own business. Oxygen is the roommate who reorganizes your life, rusts your bike, and still expects you to thank it for being alive. Today we're doing oxygen, and yes, it's everywhere, including inside your very hydrated meat suit. This is oxygen. Symbol O, atomic number 8. If the periodic table had main characters, oxygen would absolutely be one of them. It's in the air, the ocean, the rocks, your blood. And basically every snack you pretend is healthy. You're breathing air that's mostly nitrogen. But your body is like, cool story. Where's the oxygen? Earth's atmosphere is about 21% oxygen gas, and that's enough to run a planet-wide life subscription. Too little and things get quiet. Too much and everything gets a little too excited. Oxygen is a non-metal in group 16, the chalcogens. That group name sounds like a villain team, and honestly, not wrong. These elements love messing with electrons, and oxygen is one of the best at it. Oxygen really likes pulling electrons toward itself. Chemistry people call that electronegativity. Normal people call it oxygen is clingy because it bonds like it's trying to win custody of your electrons. In the atmosphere, oxygen is usually O2. That's two oxygen atoms bonded together, floating around like a tiny molecular duo. It's stable enough to exist, but reactive enough to cause drama when conditions are right. Here's the trick. Oxygen doesn't usually explode into action on its own. It helps other stuff react faster, releasing energy as heat and light. So oxygen isn't fire, it's the hype crew that turns a spark into a full performance. That's why just add oxygen is sometimes brilliant and sometimes a terrible plan. In a hospital, oxygen helps people breathe. In a pure oxygen environment, even normal materials can burn way easier than you'd expect. Oxygen is helpful, not harmless. Now let's talk about oxygen's favorite hobby, bonding with basically everything. Oxygen forms oxides with metals and non-metals. This one habit explains rust, a huge chunk of rocks, and most of the "why is this breaking" moments in your life. Rust is iron bonding with oxygen, often with water helping out. Iron plus oxygen plus moisture equals that flaky reddish-brown layer on cars, tools, and your patience. Oxygen plays the long game. It doesn't rush, it waits. And oxygen isn't just in the air. Most of Earth's oxygen is locked up in minerals and rocks, not floating above your head. Your atmosphere is the visible checking account. Earth's crust is the giant savings account you can't easily access. Look at common minerals like quartz. Quartz is mostly silicon and oxygen, arranged in a repeating crystal structure. It's like oxygen is holding hands with silicon forever, and the result is rocks you step on. And then there's water. H2O is simple on paper, but oxygen makes water weird in a way that life depends on. Oxygen pulls electrons toward itself, making water polar, which is why water dissolves salts and helps chemistry actually happen. Water polarity is why oceans exist as oceans, not as a confusing puddle situation. It's why soap works. It's why your cells can move ions around. Oxygen basically gave water a personality, and now the planet has consequences. Also, oxygen makes a lot of acids possible. In many molecules, oxygen stabilizes negative charge, making it easier for certain compounds to donate hydrogen ions. That's why oxygen shows up in lots of acids. and why your stomach can be a science experiment without your consent. Okay, let's get into the biology. Oxygen is the big reason complex animals can run high-energy lifestyles like thinking and running and stressing about emails. Your body uses oxygen to make energy efficiently, and it does it inside mitochondria. Mitochondria are the tiny cell structures that process fuel into ATP, the cell's energy currency. Oxygen acts as the final electron acceptor in the chain, which allows the whole system to keep flowing. Without oxygen, the energy output drops hard. When oxygen is limited, your body switches to less efficient energy pathways. That's where you get that "my legs are turning into sadness" feeling during intense exercise. It's not you being weak, it's chemistry being honest. And by mass, oxygen is the most abundant element in your body. Not because you're full of air, but because you're full of water and oxygen-rich biomolecules. Congratulations! You are mostly oxygen plus water plus a nervous system that overreacts to notifications. Now let's talk about oxygen's other form, ozone. Normal oxygen is O2, ozone is O3, and ozone is oxygen's chaotic cousin who shows up uninvited and changes the whole vibe. Up in the stratosphere, ozone forms the ozone layer, which absorbs harmful ultraviolet radiation from the sun. That's good. That's protective. That's thank you atmosphere. Without it, life on land would have had a much harder time. But down near the ground, ozone is not your friend. Ground-level ozone can irritate lungs and harm plants because it's highly reactive. So ozone is a hero in the sky and a menace at street level. Context matters. Now for a fun physics party trick, oxygen gas is slightly attracted to magnets. O2 is paramagnetic because it has unpaired electrons. So yes, oxygen is quietly magnetic-ish, which sounds fake until you see it, and then you start questioning everything. Oxygen also has isotopes like oxygen-16, oxygen-17, and oxygen-18. Most oxygen is oxygen-16, but those tiny isotope differences matter a lot in science. Scientists use oxygen isotope ratios as clues to past climates in ice cores and ocean sediments. So oxygen is not just breathing stuff, it's also a forensic tool for Earth's history. Tiny atomic differences become a giant timeline because the planet is a nerd and keeps receipts. Now let's rewind Earth's story. Early Earth didn't have much free oxygen gas in the atmosphere. The big change came from photosynthesis, mostly from ancient microbes like cyanobacteria, pumping out oxygen as a waste product. Yes, waste product. Plants and algae weren't trying to make oxygen for you. They were just doing chemistry to capture energy from sunlight, and oxygen leaked out like, oops. Over time, that oxygen reacted with iron and other materials in oceans and rocks. Only after those oxygen sinks filled up did oxygen start accumulating in the atmosphere. This slow transformation is tied to what we call the Great Oxidation event. And that event reshaped everything. Oxygen enabled more efficient energy use, which allowed larger, more complex life to evolve. It also made a lot of early organisms very unhappy because oxygen is great, unless it's toxic to you. Because oxygen can be toxic at high levels. It forms reactive oxygen species that can damage cells if not controlled. That's why your body has antioxidants and enzymes that manage oxygen's spicy side. So oxygen is essential, but it's also a controlled substance inside your biology. Like caffeine, but for cellular chemistry. Enough to function, not enough to set the system on fire. Now, the industrial world. We make oxygen by separating it from air, often through fractional distillation of liquid air. Cool air until it becomes liquid, then separate nitrogen, oxygen, and argon by their boiling points. It's like sorting a cosmic soup by temperature. Liquid oxygen, often called LOX, is used in rocketry as an oxidizer. It helps fuel burn efficiently in rocket engines because rockets don't get to borrow oxygen from the atmosphere in space. So rockets bring their own oxygen because space is rude like that. Oxygen is also huge in steel making. Oxygen blown into molten iron helps reduce carbon and remove impurities. That's how you turn a messy melt into useful steel, which becomes buildings, cars, tools, and your latest home project regret. Oxygen is used in medical therapy too, when people can't get enough oxygen into their blood. It can help in respiratory illness, recovery, and high-altitude situations. Again, oxygen is a tool, not a miracle. Dosage and context matter. Oxygen also shows up in water treatment, chemical manufacturing, and all sorts of industrial oxidation processes. If a process needs electrons moved around efficiently, oxygen is often invited. Oxygen doesn't RSVP, maybe it shows up. Now let's crush a couple myths while we're here. Myth: fresh air smell is oxygen. Reality: oxygen has no smell. That fresh smell after storms is often ozone and other compounds, not oxygen itself. Another myth: plants produce oxygen 24/7. Reality: plants produce oxygen during photosynthesis in light, but they also use oxygen for cellular respiration day and night. Plants are not oxygen vending machines. They are living organisms doing both sides of metabolism. Now let's zoom out to why oxygen reacts so much. Oxygen likes gaining electrons to complete its valence shell. That drive leads to strong bonds in many compounds, like water and carbon dioxide and countless oxides. Oxygen's bond patterns also explain why it's so common in biological molecules. Sugars, alcohols, proteins, fats, DNA, oxygen shows up everywhere because it helps create stable structures and useful chemistry. Oxygen is the reliable ingredient that still manages to be dramatic. And oxygen is also a reason Earth has such rich geology. When oxygen bonds with silicon and metals, you get silicates and oxides, which make up a lot of Earth's crust. Rocks are basically oxygen's long-term relationships. So the big picture is this: oxygen is a planetary system operator. It drives metabolism, shapes minerals, supports oceans, and controls huge parts of atmospheric chemistry. It's common, but it's not simple. And it's the perfect bridge to what's coming next in the series. Because as we keep moving, we run into elements that are even more aggressive about electrons. Oxygen is reactive. Some upcoming elements are aggressively enthusiastic. Oxygen is life support, rock builder, rust artist, and reaction accelerator. It's the element that powers you, shapes Earth, and still finds time to ruin metal for fun. Next up, we keep climbing the periodic table and meet the elements that make oxygen look surprisingly chill.